We're solving Leetcode 2684. The problem name is maximum number of moves in a grid. So basically it is a medium level question of Leetcode. But the question is saying basically you are given a zero index m cross n matrix grid consisting of positive numbers. You can start at any cell in the first column of the matrix and traverse the grid in the following way. For a cell, row comma column, we can basically go to like, and this is my given cell. We can go to the next column to upper row, same row, or the below row. So these are the operation allowed, and we can also only move in this direction if the current value is strictly the next value is strictly bigger than the current value. So basically we need to find the maximum number of moves that can be performed. So let's see the first example. So this is the matrix given. We need to start from the first column. So let's say we have taken 2. Now we can move here, here, or here. So we can only move if the next element is greater than the current element. So we can move here 4. It is the greater element, so we have moved here. Now we will check in all the 3 directions whether it can be achieved using 4. We are from 4 we can reach 9 because it is greater than 4. We have reached here. Now we'll check all the 3 conditions. It is fulfilling, and we can reach we can so basically the maximum path after performing the operation like this is basically 3. So the first operation is 2 to 4, and then 4 to 9, and 9 to 11. So number of operation is 3, so my answer is 3. In the second example, what we are given is basically this matrix, so its answer would be 0 because from the first column we are not getting any pair such that the next element is strictly greater than the current element. So 3 is the greatest element for all the 3 cases, 2 is the greatest element for all the 3 cases, and 1 is the greatest element in all the 3 cases. So let's see how we will do it. We will be doing it is, first of all, we will be making a DP. Let's say let's take this as a first example really. And first of all, I will fill the last column as 1 1 1 1 because it is the maximum length of the subsequence, or not subsequence, the basically the traversal, the sequence. So let's say 5 only, so we are taking the itself element as 1 only. Now we will be starting from traversal from the back. We will start from here to the front. So we will start from here and from the bottom only. Now 13 we will compare with all the 3 values. For the first value, it is the next value is greater than 13? No. Then we will come here. It is 13 is greater than 15 is greater than 13. Yes, it is greater. And we will see what is its value. It is 1. So basically we will convert it into 2. Okay. Now for the next element 2, we will check whether it is greater than 2. Yes, it is greater than 2. What is the value? 1. Okay. Now we will see this. It is greater than 2. It is greater than, what is the value? 1. Okay. So my maximum value till now is 1 only. I will check 15. Is 15 greater than 2? Yes, it is greater than 2. What is the value? It is 1 only. So we will just convert into 1 plus 1, 2. I will add 1 to the previous maximum value. Now I will reach here 9. I will check from the first condition. Is 5 greater than 9? No. Is 3 greater than 9? No. Is 11 greater than 9? Yes, it is true. So what is my greatest element is 11. So what is its count of subsequent starting from 11 is 1 only. So 1 plus 1 equal to 2. Now I am standing at 3. It is out of boundary. Is 5 greater than 3? Yes. Greater than 3. What is the value? 1. So maximum till now is 1. Is 3 is greater than is 3 is strictly greater than 3? No, it is not. So my maximum till now is 1. I will just convert it into plus 1. Okay. Now I will come at index 1. Index 1 row column. Now for the last element, we can also start from the first, but I'm starting from the last row. Now for the last row, we'll check 2 is greater than 9. No. 13 is greater than. What is the count? 2. So maximum till now is 2, and I will increment it by 1 equal to 3. Now I'm standing at 4. Is 9 greater than? Yes, it is greater than. What is the value? 9. What is the value? 9. What is the count in DP? It is 2. So I have named it as DP matrix. Okay. Now is 2 greater than 4? No. Is 13 greater than 4? Yes. What is the count? 2. So maximum till now is 2. I will increment 1 to it. It will become 3. Similarly for 4, 9 is only the greatest element. Its count equal to 2. So it will become 3. Similarly for this 4, it will become 3. It will become 3. Uh, Now I will come to the last index. Now starting from 10, is there any element greater than 4? No, it's not. So what I will do is I will just convert it into 0. There is no element. Okay, so 0 is the maximum till now, and so I will increment it by 1, so it will become 1. So 3, yes, 3, 4 is there, 4 is there, 9 is there, all are greater than the 3. So but it's the maximum DP count, it's 3 only. 3 plus 1 equal to 4. Similar for 5, I am not getting any values greater than 5, so it will become 0, and will increment 1 to 0, so it will become 1. Similarly 2, it will become 4. At last we will check this index and will find the maximum value. So maximum value is equal to 4, and I will return 4 minus 1, which is equal to 3. Okay, so basically why I am subtracting 1 from the answer, it is because it is giving the number of element in the sequence, not the number of operation. Number of operation will always be 1 minus the total number of values in the sequence. So let's see the code. So this is my solution in the solution class. This is my max moves function, which is expecting a grade, accepting a grade. Now I have also a answer variable, which I have initialized by 0. M is the grid number of rows, N is the number of columns. I have initialized a db of length m of dimension m into n. And for the last column, I am just initializing all the values by 1. And now what I'm doing, I will iterate from the last column to the first column to the 0th column, and at each column I will traverse from m-1 row to 0th row. And what I am maintaining is 3 options, which is row -1, same row, and row +1 for the next column. So if it is possible, I will store it into my option 1. If it is out of boundary, I will just place it as 0. Similarly for option 1, I will be storing grid of dpi comma j plus 1. First of all, I am checking a condition whether the grade of my current value is strictly smaller than the next grade. Okay. So similarly, I am doing this with option 3 for the increment row, for row I plus 1. I am done initializing a value which is the maximum of all the three columns, all the three options, and what I'm doing is setting the value of the current cell as the value +1. And what I'm doing, I need to find the maximum of the 0th column. So what I'm doing is whenever I am at the 0th column, I am just modifying the value of the answer by the maximum of answer, comma, value +1, or we can say the current value of the DP of the 0th index of a particular cell. So at last what I'm doing is, as well, I will return answer -1 because we need to find the number of steps, not the number of elements. So it will always be one smaller than the number of elements in the sequence. Thank you.